Hi everybody! So in today's video we're going to be looking at equations that have variables on both sides. So if we look at example 1, the only difference between the equations we've already been solving and the equations we're going to focus on today is that the equations we're going to focus on today have an x on both the left side and the right side of the equal sign. So here's what we're going to do. We're still going to start the same way, drawing a vertical line through our equal sign. Now we need to get the x's together. In other words, there's an x on the left and an x on the right. We need them to move so they're on the same side. So what I'm going to do is I'm going to subtract 4x on both sides. Now when I do that, on the right-hand side, the 4 x's cancel. On the left-hand side, I'm going to copy down the 7, and then I'm going to combine the like terms. So negative 8x minus 4x gives me negative 12x. And then on the right-hand side, I'm just going to drop down the minus 17. Next, I'm going to subtract 7 on both sides because subtraction is the inverse of addition, and this is a positive 7, so I need to undo having a positive number, which means I'm going to drop down the negative 12x, and negative 17 minus 7 gives me negative 24. Finally, I'm going to divide by negative 12 on both sides. And I get x equals negative 24 divided by negative 12 is 2. Now let's take a look at problem 2. So in problem 2, I'm going to start the same way, drawing a vertical line through the equal sign. Now because the negative 3m and the 24 are on the left side, and the right side only has a 5m, instead of subtracting 5m to move it to this side, I'm going to add 3m to move it to the other side. Now when I do that, the negative 3m cancels the 3m, and I'm going to drop down the 24. 5m and 3m are like terms, so I'm going to combine them, and I'm going to have 8m. And finally, I'm going to divide by 8 on both sides because division is the inverse of multiplication. 24 divided by 8 gives me 3 equals m. Next, let's take a look at number 3. So in number 3, I'm still going to start the same way. I'm going to draw that line through my equal sign. Now I'm noticing that in this problem there's a parentheses, which means my first step is going to be to distribute. So I'm going to have 6z minus 8 when I distribute that 2. Then I'm going to drop down the 5z minus 2. Now I need to get my variables together. So there are z's on the left and z's on the right, which means I'm going to subtract 6z on both sides in order to get them together. Now when I do that, the 6z cancels on the left and on the right, and on the left side, 5z minus 6z, those are like terms. And I'm going to have negative 1z. Then I'm going to drop down the minus 2 and the negative 8. Next, I'm going to add 2 on both sides, and I'm going to get negative 1z, which I'm just dropping down, and these 2's are canceling, equals negative 8 plus 2, which is negative 6. And finally, I'm going to get the z by itself by dividing by negative 1 on both sides, which means I'm going to have z equals negative 6 divided by negative 1, which is positive 6. we're going to go ahead and save these two problems for tomorrow in case we need some more examples to do. And we're going to move on to page 41. Now, one thing that we need to emphasize is that every equation has either one solution, infinitely many solution, or no solutions. Some equations have exactly one answer. So when we think about that, that means only one value of x makes that equation true. If I look at this example, if I draw my vertical line through my equal sign, the first thing I'm going to need to do is get the x's together. So I'm going to subtract 2x on both sides. When I do that, the two x's cancel on the right. And on the left, I'm going to combine the like terms. So 3x minus 2x would be 1x. I'm going to go ahead and drop down the minus 5. And I'm going to drop down the 7. Next, I'm going to add 5 on both sides because addition is the inverse of subtraction. And I'm just going to have 1x equals 7 plus 5, which is 12. And since this is a 1, I don't really need it there, so I don't need to divide in order to get x by itself. The answer would just be x is 12. In other words, this is the only value of x that makes this equation true. However, there are some equations that have infinitely many solutions. In other words, there are many, many correct answers. So lots and lots of x values make the equation true. For example, in this problem, my first step would be to distribute because I've got a parentheses and I need to get rid of it. So I would get 2x plus 10, and then I would have the other side, I'm just going to copy it down. Now, if I stop and look at that, what I noticed is that these two sides are exactly the same. Since these two sides are exactly the same, no matter what value of x we use, we're going to get the exact same answer on the left and the right. So what we would say is that there are infinitely, meaning an infinite number, many correct answers. Because literally every number would always work, since 2x plus 10 is always going to give you the same value as 2x plus 10. Finally, some equations have no answers. There are no possible x values that make them true. So for example, if I was trying to solve this equation and I distributed first to get rid of the parentheses, which means I would have 3x plus 12 equals 3x. The next thing I would probably do is subtract 3x on both sides in order to get the x's together. And the 3x would cancel on both sides. So my answer would be 0, because there's nothing left on the left side, equals 12, because the only thing on the right side is a 12. Well, the number 0 is never going to equal the number 12. Never, ever, ever. No matter what you do, 0 is never going to equal 12. So we would say that there are no solutions to this equation because there are no numbers that would ever make this equation true, that would ever make it so 0 would equal 12. All right, thank you guys so much for watching. Have a great afternoon, and I will see you tomorrow for some practice.